So good morning all. In this section we will see Poynting's theorem and its derivation. So we know that electromagnetic waves have energy and momentum, and this energy can be transferred from the source to any distant point, and that energy required to transfer from the source to any distant point is computed using Poynting's theorem. Poynting's theorem states that the vector P, this vector P is otherwise known as Poynting's vector. Vector P is equal to E cross H, where E is electric field intensity and H is the magnetic field intensity. At any point is a measure of rate of energy flow per unit area at that point. So Poynting's theorem helps you to measure energy flow per unit area, or otherwise known as energy density. If you can calculate energy density, then you can calculate power density also using Poynting's theorem. So in short, we can say that Poynting's theorem is used to measure either energy density or power density at a particular point. Simply, it's enough to take the cross product of electric field intensity and magnetic field intensity. Now, we will see the derivation starting from Maxwell's fundamental laws. Del cross E is equal to minus dou B by dou T, and you know B is equal to mu H. When you substitute, you can write del cross E is equal to minus mu into dou H by dou T. Similarly, you have del H is equal to J plus JD, and that is written as sigma E plus dou D by dou T. Then D you can substitute as epsilon E. So finally you can write del cross H is equal to sigma E plus epsilon dou E by dou T. That is equation 2, and this is equation 1. Now what I am going to do is I am going to dot this equation 2 with respect to E. So while dotting, what I will do is I will be placing this E on the left hand side of del cross H and on the left hand side of sigma E plus epsilon dou E by dou T. Okay, I am dotting equation 2 with E such that E will be placed on the left hand side of del cross H as well as left hand side of sigma E plus epsilon dou E by dou T. So I have written here E dot del cross H is equal to E dot sigma E plus epsilon dou E by dou T. That is equal to, removing the bracket, sigma E square plus E epsilon dou E by dou T, which is my equation 3. Now we have a vector identity del dot A cross B is equal to B dot del cross A minus A dot del cross B. Now we are using this vector identity to simplify equation 3. So what I am going to do is I am going to apply this vector identity for E and H. This is A and B, where A and B are any two vectors. Now in this particular derivation, that any two vectors are E and H. Okay, so what I can do is, so instead of B I will be placing what? E. I will be placing E, and instead of A I will be placing what? H. Okay, instead of A I will be placing H. So I am applying equation 4 for E and H such that here instead of A I will substitute H, and instead of B I will substitute E. So I can write del dot H cross E is equal to E dot del cross H minus H dot del cross E. Okay, that's all. I am simply substituting that identity in equation 3. So here it is written del dot H cross E is equal to E dot del cross H minus H dot del cross E. Now I am simply rewriting the equation such that E dot del cross H is equal to del dot H cross E plus H dot del cross E. I am taking this term to one side and the remaining term to the other side, so that I can write E dot del cross H is equal to del dot H cross E plus H dot del cross E. Okay, that is my equation 5. Now what I am going to do is I am going to substitute equation 5 in equation 3. So what is equation 3? Equation 3 is E dot del cross H is equal to sigma E square plus E into epsilon dou E by dou T. And what is equation 5? It is E dot del cross H is equal to del dot H cross E plus H dot del cross E. So I am substituting 5 in 3 so that I can write del dot H cross E plus H dot del cross E is equal to sigma E square plus epsilon E dou E by dou T, which I am further rewriting as del dot H cross E is equal to del dot H cross E plus H dot del cross E is equal to sigma E square plus half epsilon dou E square by dou T square. When we consider this equation and this one, all terms except the last term is the same. The last term, instead of E epsilon dou E by dou T, I have rewritten as half epsilon dou E square by dou T. Now here you can see, we have already studied that dou x square by dou T is equal to 2x into dou x by dou T. So making use of that principle, I have rewritten the last term. So see the last term in equation 6, it is written as half into epsilon dou E square by dou T. So I can write that as, based on this principle, I can write this last term of equation 6 as what? Half epsilon 2E into dou E by dou T, which is same as this term, which will be same as this term. Hope it is clear. So that is my equation 6. Now as I dotted this equation 2 with E, what I am going to do is I am going to dot both sides of equation 1, that is this one with H. Okay, this one with H. So that is written here, H dot del cross E is equal to H dot minus of mu dou H by dou T. So H dot del cross E is equal to half mu dou x square by dou T. Here also we are using the same principle, that is here this one, that is dou x square by dou T is equal to 2x dou x by dou T. So here just see this term of equation 7, if I am differentiating is it minus half mu into, I will get 2h into dou H by dou T. So 2 and 2 get cancelled and I will get this term, which one, H naught into minus mu dou H by dou T. So I am slightly rearranging this one like this one based on this principle. Okay, that is my equation 7. Now I am going to substitute 7 and 6. Okay, 7 in 6. 7 is H dot del cross E. In 6, the second term is H dot del cross E. So I am substituting. So I will get del dot H cross E is equal to half minus half mu dou x square by dou T, which is equal to sigma E square plus half epsilon dou E square by dou T. Then I am slightly rearranging. Del dot H cross E is equal to half mu dou H square by dou T plus sigma E square plus half epsilon dou E square by dou T. So then here it is written as H cross E. Now I am slightly reversing the order so that I can write del dot E cross H. Here it is written as H cross E. Here I am writing as E cross H. That is equal to minus sigma E square minus half epsilon dou E square by dou T. Here it is dou T minus half mu dou H square by dou T square. This equation and this equation both are the same except change in sign. The reason is when the order is reversed, the cross product changes its direction. So when you take the cross product of H cross E, sometimes you will be getting a vector, positive vector. And if you take the cross product of E cross H, you will be getting the same vector with a negative sign. That is a property of cross product. That is, if the order get reversed, the magnitude remains the same but the direction changes. That is why in this equation all the terms were positive and in this equation the terms became negative. That's all. So in the next step what I am going to do is I am going to take the volume integral, so that I can write as integral V is equal to del dot E cross H dV is equal to minus dou by dou T of this two terms. The last two terms is combined as a single term. So that is written as minus dou by dou T volume integral of half epsilon E square plus half mu H square dou V minus volume integral of sigma E square dou V. That is my equation 8. Now coming to divergence theorem, if A is any vector, you know surface integral of A dot ds is equal to volume integral of del dot A dV. Now I am going to apply this theorem in equation 8 so that I can write, here it is del dot E cross H dV, it is here. So based on the divergence theorem I can write it as what? Surface integral of E cross ds. So applying this theorem to E cross H, that means here this E cross H is equal to what? A. This is, so instead of A you have to substitute E cross H. So I can write surface integral of E cross H ds is equal to what? Volume integral of del dot E cross H dV. That is my equation 9. Now I am substituting 9 in 8. So the left hand side of 9 and 8 is, here you can see this is del dot volume integral of del dot E cross H dV, and here you can see what? Volume integral of del dot E cross H dV. So I can substitute, write the equation as surface integral of E cross H ds is equal to minus dou by dou T integral half epsilon E square plus half mu H square dV minus integral sigma E square dV. We are only changing this one. Only the left hand side of equation 8 is being changed based on divergence theorem. The right hand side remains the same, where this term, the first term represents the total power leaving the volume, and the first term on the right hand side represents the rate of decrease in energy stored in electric and magnetic field, and the second term on the right hand side gives you the conduction loss. So I repeat, the first term, this one on the left hand side gives you the total power leaving, then on the right hand side the first term gives you the rate of decrease in energy, and the last term the conduction loss. And this is your Poynting's theorem. Hope the derivation is clear.